All right, class. In the last video, I believe I stopped off at problem B. I think we finished problem A. So we're going to be looking at this particular function. We're looking at, this is going to be a vertical shift, right? And so again, I'm going to take that middle number, x plus 2, set that equal to 0. My new number is x is equal to negative 2. So this is telling me I am shifting to the left 2 units. And so if we think of the function, right, if my point is 2 comma 10, this means, sorry, 2 comma 5, this is implying that the only thing that is changing is the x values, not the y values. So because it's just a vertical shift, so my y value is going to stay the same. And because I'm moving 2 to the left, this means that my new point is going to be 0. So I'm going to have 0 comma 5. Okay. All right. In C, I can tell that this is going to be a horizontal shift, right? So my original point is 2 comma 5 because, sorry, not a horizontal. This is going to be a vertical shift. That means I'm moving upward 2 units. So that's only affecting the y value. So then that means that my x value will stay the same, but I'm going to move 8 units up higher on the y value. So I take 5 plus 8, and that's going to give me 13. So my new point would be 2 comma 13. Okay. Now D is a little bit different because notice that 4 right here, this is going to be that horizontal dilation. So that means that we're now compressing by a factor of 1/4. Okay, so we're compressing by a factor of 1/4. And so this means that our value, our original point is 2 comma 5. So this is going to affect the compression of 1/4. So now I'm going to take this x value and it's going to become 2 times 1/4, which is equal to 1/2. So therefore my new point is going to be 1/2 comma 5, because I'm compressing by 1/4. Okay. So E is I am now, because it is 1/3, I'm actually, this is a stretch. It's still a horizontal stretch, but it's going to be a stretch by a factor of 3. Because remember, the compressing and the stretching for the horizontal is always by a factor of 1/b when I'm looking at f of b of x. So that's why I end up looking at the reciprocal of these numbers. So that means that now my point from 2 comma 5 is going to turn into 6 comma, and I got 6 from 2 times 3, 6 comma 5, but that that k stays the same. Okay. All right, let's take a look at this in Desmos real quick, just so that we can get a sense for this. Oops, I don't think it worked. So in Desmos, I think the function I told everybody that I was going to use was going to be x squared plus 1. And the reason why I'm using this function is because when I plug in the point 2 comma 5, it's on that function. I could have used any other function. I'm just using this as an example for us to see the translation. Whoops. Let's do this again. 2 comma 5. And so notice how that point is there, 2 comma 5. So now, particularly, let's look at the compression. So the compression was, I was applying, I believe it was 1/4. Oh no, I think the first one was 4x. So that would look like 4x shift raised to the second power plus 1. And so this becomes our new parabola, right? And so this is the same thing as what I wrote. Let me go back to the document so you can see it. So that's what we were looking at here in this problem right here. See, it's 4x. So I'm plugging in 4x everywhere I see that x value in the function. So going back over here, that's why I have 4x here. So the point that we said, we basically took 2 and we multiplied it by 1/4 and we got 1/2. So then we should end up with 1/2 is the new point, comma 5. And notice that's exactly what we wanted right there. So it is the new point. It's still in the function, and that's our new point once we moved from the red to the purple. Now the other one that we looked at towards the end was now if we applied 1/3. So here's 1 divided by 3. And then this is still x, and now we're gonna, whoops. We're going to go ahead and raise this to the second power, and then we're going to add 1. So this is the new function we were just looking at, the red function. And so our new point here, right, we took the original point 2/5, and now because we're doing a horizontal compression of 1/3, we are multiplying the 2 by 3 because we're multiplying by the reciprocal. So that new point really should be 6, 5, and let's just double check that it lands on our parabola, and it does. Here it is. So 2, 5 in the first compression, right, to that purple graph became half of 5, and then that 2, 5 became 6, 5 when we did the compression of 1/3. Okay, so I hope that that helps with those particular questions. Let's kind of come back over here to our notes that we were working on. And so that covers all of these. So now for number 8, it says write an equation for a function that has a graph with the given characteristics. So here we're taking a look at the parent function x cubed. And, oops. Looking at the function x cubed that's reflected on the x-axis, right? So that means that we're going to take negative x cubed, x-axis, and it's shifted left 2 units. So left, I'm moving this way, which means I'm going to be in the negative. So because it's a left shift, we know that it's going to affect the x itself. So the new function will be f of x is equal to negative, and then again I'm shifting to the left, so it's going to be plus 2 cubed.
Can I go to the bathroom?
And so now let's look at the next one. The shape is y equals the absolute value of x, but it's shifted to the right 3 units, and it's up 7 units. So we're going to start off with the parent function. Let's start off with the 7 units that's being, sorry, the right units. So we're going to the right now. So now that's going to be x minus 3 absolute value, and we're going up 7 units, so that's going to be plus 7. Okay. All right, the shape is, so we're looking at the function f of x. Oops. We're looking at f of x is equal to 1 over x. It's going to be shrunk horizontally by a factor of 3. So because we are going to be compressing this by a factor of 3, that means that within here, this is going to be 1 over 1/3 x. And then it's going to be shifted up 2 units. Those 2 units come on the outside. Okay? Now, I could rewrite this, and I was talking to a couple of students regarding complex fractions. So this is the same thing as 3 over x plus 2. It simplifies to this. Okay, and the reason for that, let me give you a side note in terms of complex fractions. When we're dealing with complex fractions, it's a fraction over a fraction, such as 1/3 over, let's say, 2/5. One way that we can do this is that we can go 1 times 5, and then the inner is 3 times 2. So it's going to be outer over inner. So the outer is 1 times 5. The inner is 3 times 2, which is 6. So this reduces to 5/6. Okay, so I can do that over here, because notice that the fraction here would be 1 over 1 all over 1/3. Okay, so 1 times 3 and 1 times 1. So therefore I would end up with 3 over 1. But this 1 really turns into x, because the x stays on that denominator. Alright, the shape of what is y equals the absolute value of x, but reflected across the y-axis and shifted left 7 units. So we're going to be looking at f of x is equal to the square root. And so now, because it's reflected around that y-axis, then that's going to be plugged into the x. And then it's going to be shifted to the left 7 units. So because I'm going to the left, I'm going to say plus 7. So I'm going to have something like this. Okay. All right. Lastly, let's take a look at this. The graph g of x is given below. State the correct order the transformations must be performed to graph the function x plus 2 minus 3. Then graph the transformed function the same graph. So the first thing we want to do for this particular function is pay attention to the inside. So if I do x plus 2 equals 0, this means that x has to be negative 2. So I'm going to be going towards the left 2 units. So we're going to start off with the left 2 units, and then we're going to shift downward 3 units, and I get that from the negative 3. So if I'm paying attention to this, I basically want to do that with all of my points. So this particular point here, 5, 9, is going to be shifted 2 units to the left, so 1, 2. But then it's going to be shifted 3 units down, so 1, 2, 3. So this is the new. This one is going to go 2 units, 1, 2, and then 3 units down, 1, 2, 3. This point is going to go 1, 2, 1, 2, 3. And lastly, this point is going to go 1, 2, and then 1, 2, 3. And so now we can go ahead and draw that function. Oh wait, I think that was the wrong one. There we go. So it's going to look something like that. And that's it. That's the end of the notes.